Okay, everybody, this is chapter 6, section 6. This is the last section for this chapter. Okay, so we're dealing with linear inequalities again. So one, we're looking at y equals mx plus b form and graphing stuff on a line, or on graphing things on a graph. But now we're working with systems. So now we're looking at two lines on a graph and looking how we're going to go back to section 5 a little bit and look at how we shade these inequalities on a graph. And what we're looking for is where does the shading kind of intersect each other. So my suggestion when you do this is to have a couple of different colored pens or pencils so that you can do that. So you have a different color for each line that you graph and each shading that you do. So if you want to pause it and get that kind of material together. Also, too, it's really good to have graph paper when you're doing these, okay? So if you want to hit pause and do that, come back and hit play and we'll get moving, but I'm just going to keep on going here, okay? So one, we just have to make sure, too, that we're having this understanding that we're using this form to be able to get a line, graph it. Okay, and then we're also remembering too that when we have these kinds of symbols, it's dashed lines. If you have this or this, it's the solid line. Okay, if you have these, I'll come down here. If you got these, I'm sorry, you got these. Hold on. You got these, you're going to shade above, okay? If you have these, you shade below, okay? But because we're going to shade two different lines, we got to find their intersection. So when we get there, I'll show you that, okay? So let's go to this first definition here, the solution. So it's any ordered pair that makes all the inequalities true. When it says all, in this case, it really just means both. Okay, because we're only working with two. Okay, an ordered pair that makes all the inequalities true. So remember, that's an x and a y. That's what ordered pair is. And the points in the overlapping shaded region. Okay, so once again, I like to make it easy for myself. So if that when I get an overlapping shaded region, I'll show you what that means in a little bit here. If the origin's there, I'm going to pick the origin as my x and y value. Okay, if the origin is not in that particular region, then I'm going to stick with picking a point that's on an axis. So at least one of my values for x or y is 0, okay, and just making it easier for myself, okay? So here we go. Once again, we're identifying my slope, identifying your b. If you want to put your slope in that form, that's great, okay? So I'm going to get -4 as my starting point, so -4 up on the y-axis. I'm going to go up 2 and over 1. Okay, and I'm just going to keep doing that all the way through my graph. I'll come back to the starting point, go down 2 and left 1, just so I'm all the way through. Okay, now you got to go back to your inequality sign that tells you a couple things to do. It's greater than, so I'll shade above. It's also, the first thing I should have done though is tells me it's going to be dashed, so I'm going to go dashed line. Going back to the inequality, it's greater than. So where do the y values get greater? They're going in that direction. So that tells me I'm shading in this direction. Now, the reason why some kids like to scribble, they're shading that they like to do this. And the reason I don't do that is because when we get to systems, I need to be a little bit neater than that. So that's why I draw those lines like that. Okay, so you might want to kind of do that with me. At least this, hope you understand why in a second. Okay, so I'm going to change colors. You might want to do that. I'm going to identify my M. I'm going to get my B. Okay, My starting point B is at positive 4 this time on the y-axis, so that's this point right here. My slope is a negative 3 over 4, so it's going to tell me to go down 3 and over 4, so down to 3, or down 3 over to 4, always go right, gets me to there. I can't really go any more points in either direction there though, so I'm going to go back to my inequality sign. I'm going to look at it. It's less than and it's equal to. So the equal to part tells me that I can draw a solid line through those points. Let's see if I could draw a straight one. Sorry. Let's see if we can draw a straight one. Kind of, guess I'm not drawing straight today. Okay, but it's less than. So once again, I'm going to draw lines. Okay, go. Now, where you see checkerboard, so I hope you understand, just do dots here in black. Where I see checkerboard, that's my overlap. That's where they're intersecting with two different graphs, okay? So that's what I'm looking for. So that's why I draw straight lines of different colors, and I look for checkerboard. That's the overlapping shaded region. I need a point from that overlapping shaded region. So if you guys will humor me here, I'm thinking that the origin is in that area, okay? But it has to go back into both inequalities and it has to work for both, okay? So remember the origin, your x and y is 0, 0. I'm going to write that down. And I have to plug it back into this first one and in the second one, and it has to be true for both. Okay, so I'll do it over here where we have solution. Okay, so putting it into the top one, my y is 0, my x is 0. Get that? 2 times 0 is 0. 0 minus 4 is negative 4. Is 0 greater than or equal to negative 4? Or greater than, sorry, put equal to on that. I'm supposed to do that. Let me get that. And that's true. So yes. But it has to go in the second one. So I'm still using the same point, which is kind of nice. And the second equation is this. So I'm going to go, my y is 0. Less than or equal to, my slope is negative 3 over 4. My x is 0 plus 4. Okay? Negative 3 times 4, negative 3 over 4 times 0 is 0. 0 plus 4 is 4. And is 0 less than or equal to 4, and it's less than? So that is yes. So my point that we found here together actually works. Okay. All right. So my suggestion: a couple different color pencils. If you don't, it's not a big deal. But I just like I like to be able to have it jump out at me a little bit so I can see it more clearly. Okay. Try to be neat when you do these. And then sometimes, once I find that it is true for both, then I might kind of go and do this and just really darken it in, because this is going to be a skill test, and we really want to make sure we see where you got it. But I don't do that till the very end. I proved it. Okay. All right. So I'm going to let you guys go ahead and do this one. What I would do here though on this second one is it's not in y equals mx plus b form. Okay. So I would do that first and then go graph it, okay? And then go ahead and shade it. Shade both of them. Remember your little rules. Go back. I'll even write them down for you again. Remember, if it's this or this, it's dashed. If it's this or this, it's solid. Okay, if it's this or this, it's above. You're shading. And if it's this or this, it's below for your shading. Okay, so, but you should have that in your notes, and you should be able to look back at it, and you know, a little bit to remember, but I don't think it's that tough. But you should have it written down somewhere to refer to. Okay, so let you guys, if you want to hit pause and graph these two, you want to graph it, find where they overlap, find a point in the overlap, plug it back into the original equation. So you're going to go back here, plug them in, and see what you get. Okay. Okay, so I'm going to identify my M and my B in the first equation. If you want to put your M in that form, that's great. -3 is my starting point. And I'm going to go up 2 and over 1, and I'm just going to keep on going. Okay, I'm going to come back down to my starting point and go in the opposite direction, so down 2 over 1. And that one is it's just less than, so that tells me dashed. Okay, and it's less than, so it tells me a shade below. Okay, so the y values were going smaller in this direction. Remember, y values getting smaller that way. Okay. My other equation, I had to go ahead and get the y by itself, so my slope is going to be this. I'll put it under 1 under it, and there's my starting point 2. So I'm going to go +2 on the y-axis. Okay, I'm going to go down 2 and over 1, and I'm going to keep on going. Oops. I'll come back to the +2. I'll go up 2 and left 1, just so I'm all the way through the graph. Okay. All right. Looking back at my inequality sign, I put equals. Sorry. Pay attention here. I did not have to change the sign when I moved it because I didn't have to divide by a negative. Okay. It was greater than and just greater than, so that's going to tell me that I'm going to go a dotted line or dashed line again. Okay. Because it's greater than, I'm going to shade above the line. Okay. And remember, once again, I'm looking for where they're checkerboards, okay? And I'm also looking to see if the origin is in that checkerboard, and it's not, okay? So what I'm going to do is pick a point on an axis, and the only axis that's in that checkerboard that I think of is the x-axis out here past 1 or 2, basically, okay? So I don't pick something that's really close. I make sure I pick something that's kind of in there. So the point that I'm going to pick is going to be 4, 0. And remember, I'm picking it because one of the values is 0. It's easy to plug in. Okay. But you got to go back to the original equations, and you got to make sure you plug it into both. Okay, for it to be true. Okay, so your x is 4, your y is 0. Plugging it into the first one, I'm going to get 0 less than 2 times 4 minus 3. 2 times 4 is 8. 8 minus 3 is going to be 5. So is 0 less than 5? And it is, so that's a yes. So it worked for the first one, okay? I'm going to go back to the second one and plug them in. So my x was 2. I'm sorry, my x was 4. My y is 0, greater than 2. 2 times 4 is 8. 8 plus 0 is 8. Is 8 greater than 2? And yes, it is. Okay. So the point that we got worked for both inequalities. Okay. All right. So, you know, there's some of those problems on your classwork. You really got to make sure that you understand what what works for both of these. Make sure you got all those little rules about how to shade, how, you know, solid or dashed, and always plug a point in and prove it. Try to get the origin, but, you know, just realize sometimes that doesn't happen. So pick an axis point to make it a little bit easier for yourself. Okay. Okay. So on this one's a little bit difficult. I don't like how it's showing up here. I've always had issues with this. I think the darkest or the overlap is going to be where it's darkest. I think it's this. I didn't look at my notes before I started, so I can't really remember, but I think that was correct. But what I want to do is write an equation for each line. So let's look at the red dashed one first, okay? First off, I'm going to identify its y-axis for its starting point. Remember, what I'm going to try to do is write it in this form. So I need a starting point, so I did get that. And then I'm going to need to find the slope, okay? So the starting point's at +5. Let's just double check. So here's 1, 2, 3, 4, 5. So my starting point is +5. Okay. It's going to be y is going to be there. X is going to be there. But now I need a slope. So what I'm going to do is I'm going to look, I think, at this point. They come together. So that's a down 1 over 2. In my book, so it's a negative slope. It's 1 over 2. Okay, I'm going to go back and change my inequality sign here. Okay, and I'm going to look, you know, where did I shade in this case? So to me, it looks like this is where I shaded on that one. I shaded above it, so that's going to be just greater than. Okay. All right, let's look at the blue solid line. So if it's solid, it's going to be equal to in one way or another. I'm going to go ahead and look at the starting point. It's at -1, so that's going to be my y-intercept. I'm looking at where it crosses. It looks like it's crossing right here. So that looks like it's up 1 over 1, so it's just going to be 1x. Or just x is fine too. And I'm going to have my y out here. Now I got to look at how I shade this. I think I'm shading above it. I think green's a little bit darker than yellow. Okay, so I think I'm shading above it. Okay. But it would be equal to because it's solid. All right. So this is where I always have issues when we get to this problem. We're not doing a very good job of shading it. To me, if I look at it on this one, maybe I'm going to go back and change one of my values. If this is green up here and it's green down here, then maybe the equal thing or greater thing for the blue line is more accurate. And so I'm looking here, this is yellow. And that's below the red line. So maybe I'm going to go back here and change this first one that we did and make it less than. Okay. So just you can always make changes, and I think that's going to work. So that would mean if I shaded below the red line, it's really this yellow, and then it mixes with the green because the green was above, and that gives me this kind of overlap. Okay, so that's why I do lines instead of shading, because checkerboard to me is a lot easier to see than when things get dark and these colors aren't great. Okay, so let's see what works. So I think that the origin is in this overlapped region. So my point's going to be 0, 0, and I'm going to go plug it back into both inequalities. Let's just see if it works. Okay, so I'm going to plug 0 in for y in the first inequality. Okay, 1/2 times 0 is 0. 0 plus 5 is 5. So is 0 less than 5? Yes, it is. Okay, let's plug it into the second one. Okay, so once again, your y is 0. greater than or equal to your x is 0 minus 1, 0. 1 times 0 is 0. 0 minus 1 is negative 1. Is 0 greater than or equal to negative 1? Yes, it is. So it was a good thing I went back and checked, and I changed that first inequality. I changed the sign. Okay. So there you go. Once again, I just don't like the way that they shade this because I'm not colorblind, but I have a hard time kind of understanding the colors and whatever. Okay. So that's why I draw straight lines on my shading instead of just shading it with scribbles. Okay. All right. So once again, it's really important you do a good job on your classwork. Please make sure that you got stuff in y equals mx plus b form when you graph these, and then make sure you're using all those little rules about lines that are dashed or solid, and then shade above or below. Okay. All right. Have a good one. Once again, if you need anything, just make sure you get a hold of me, and I'll give you some help and get it figured out.